In our today's class, we will study verification of Ohm's law. That how Ohm's law is to be verified. For this, the necessary setup is like this. You just put one resistance. In parallel to that, put one voltmeter. In series with the resistance, put an ammeter. With the help of some battery, we need to apply some potential difference. We need to have a switch. Also, we have to have a rheostat. Rheostat means this is variable resistance. And this is the sliding contact of the rheostat. With the help of this sliding contact, we will ensure that at different times, different quantity of the potential difference is applied. Sometimes less resistance will be taken in circuit, more voltage will go. Sometimes more circuit resistance will be taken in circuit, so less voltage will go. We will vary voltage with the help of rheostat. That is the purpose. And as the statement of Ohm's law is like this, the current flowing through a conductor is directly proportional to the potential difference applied across its ends, keeping the temperature and physical conditions of the resistance same. Here we have taken already one resistance. Its temperature we will try to minimize, rather we will try to keep the temperature constant, and physical conditions means length and area of cross section will not change. That of course we will not change. Having this setup in place, now our only aim to verify Ohm's law is to verify that current is directly proportional to potential difference. The basic operation that you can do is just by noting down here in this setup, put the switch on, current will start flowing. Because the potential difference is applied, current will start flowing. With the help of this, ensure that different amounts of potential difference is applied across the resistance. Say as with the help of this setting, you are initially applying 10 volt, and that time let us assume that ammeter is reading as 1 ampere of current. Now with this reading, with the help of this sliding contact, change the potential difference and make it say as 20 volt, that you will be able to read here. And say for 20 volt this is reading as 2 ampere. And then further make it 30, you will find that this is 3 ampere. So this is one way verification of Ohm's law. You have doubled the potential difference, current got doubled. You have tripled the potential difference, current got tripled. This is one simple observation. Now if these values 0, 10, 20, 30 and 1, 2, 3 amperes, if you draw a graph between the current taking on y-axis in amperes and potential difference taking on x-axis, a potential difference in volts, the values that I have suggested are kept simple so that a simple calculation can be made. Now when this current and potential difference graph is taken, you see that it is a straight line passing through origin. A graph of between the two quantities when is plotted and that graph happens to be a straight line passing through origin, undoubtedly those two quantities which were represented by this, or which this graph was representing or still representing, those quantities are directly proportional to each other. A straight line passing through origin graph can be possible only if the two quantities for which this has been the representation are directly proportional to each other. The third way is current is directly proportional to V. Also you can say V, that is potential difference is directly proportional to I, or V is equal to I into R. If I keep R here, it becomes V upon I. Now if I want to prove current is directly proportional to potential difference, it is also sufficient for us to prove that for different values of potential difference that we applied, and consequently the current values that were changing, if their ratios is always same, then again we say current flowing through the conductor is directly proportional to the potential difference, which is the statement of Ohm's law. So Ohm's law is verified by this also, that if you find when it is 10 and 1 ampere, the resistance is 10 ohm. When this is 20 and 2, again it is 10 ohm. When it is 30 and 3, again it is 10 ohm. So resistance being constant, verification of Ohm's law. The current and voltage graph being a straight line, it is also verification of law. And also we observe by standing near to the our setup that when we doubled the potential difference, the current also doubled. This was all about verification of Ohm's law.